अच्छा ठीक है so we are done with ionization energies ठीक है we are done ionization energies across the period right this was the last thing that we were doing that they increase we did explain why there are dips that are occurring at group 3 and also group 6 and also remember that when you move across a period ठीक है just a second let me open the periodic table. So when you move across the period, what happens is that once the period ends, you move to a period that's lower down. Okay? Down the group, ionization energy decreases. So the trend is always the same, but it's lower. Okay? So this one, the next period, like period number 3, that's it's going to follow the same trend, but it's down the group. You're moving downwards. So which is why it kind of becomes easier to remove electrons, because when you move down the group, what happened when you move down the group? When you go down, the number of shells increase, so it kind of becomes easier to remove electrons. So the trend is exactly the same when you're moving across a period. But as soon as you move to the next period that's lower down, you've got bigger atoms, the electrons are further away. So the trend is exactly the same except that it's lower. Is this point clear?
So can you repeat that? I did not get it.
I was saying yesterday we were talking about ionization energies across the period, right? So I told you a couple of things. I told you that when you move across the period, you've got more protons, right? Uh, like over here, you've got 9 protons, fluorine. Over here, lithium has 3 protons. So it becomes harder and harder, more difficult to remove electrons. More protons means a stronger attraction for electrons. The distance also slightly decreases when you move across the period, right? And they have the same number of inner shells. That means the shielding is constant when you move across the period. So because of all these factors, and specifically because you have got more protons, it becomes harder and more difficult to remove electrons. So across the period, ionization energies, they constantly increase. Okay? Is this clear?
Yes.
And then we talked about the dips at group 3 and group 6. Okay, I told you that was because of the orbitals changing. Like beryllium, electron is being removed from the 2s. In boron, the electron is removed from a slightly further orbital, the 2p. So it becomes kind of easier to remove electrons. And we talked about the dip at group 6. Like if you're removing an electron from 2p3, in 2p4 it's easier to remove electrons because uh, the electrons are removed from a paired p orbital, which means like if you have 4 electrons, it's removed from a paired p orbital. So there's a mutual electrons and electrons are repelling each other, so it kind of becomes easier to remove electrons. So which is why the dips are appearing. The dips appear because of something going wrong in the orbitals, right? So we did all of this. What I'm trying to explain now is that when you cross one period, right, ionization energies constantly increase. They move to the right, they constantly increase, right? Then you move to the next period. The same trend is followed. Okay? Abdullah, is this clear?
Yes, sir.
Except that for the next period, it's going to be exactly the same trend. Dips at group 3, group 6, everything would be exactly the same. Except for one thing, and that is that the ionization energies are going to be lesser. Because when you move downwards, the size of the atom becomes bigger. So the electron is much further away. So it kind of becomes easier to remove electrons. So for all of them, like if you compare the first period with the next period, in the period that's lower down, it's easier to remove electrons because they're bigger atoms. The electrons are much further away. Hence, your ionization energies of the third period would be lower compared to the ionization energies of the second period. Is this clear?
Yes, sir.
And also remember that when you move to the fourth period, you have transition metals as well. These transition metals also come in the way. Like in the first period, there's just 2 elements. In the second one, there are 8 elements. In the third one, there are also 8 elements. When you move to the fourth period, there are 10 additional transition metal atoms as well. So I'm just going to copy another graph, let's say for the ionization energies across the period. So so this one, this one. So just wanting to show you the graphs across a period. So hopefully you can see this. So the sketch is the same. Rises, dips at group 3, rises, dips at group 6, rises again, right? The dashes are not drawn, so what I can do is, you can obviously, hopefully see them. So it's the same trend. The first period only has 2 elements. There's a rise. The second and the third period have 8 elements. When you move to the fourth period, you've got these transition metals as well that are kind of, these ones are transition metals. Their ionization energies are not in your exam or their comparisons, but if you see them in the graph, don't get confused. The trend is exactly the same. Group 1, group 2, then there's a dip at group 3. Then group 4, 5, then there's a dip at group 6. Except that in period number 4 and period number 5, there would be 10 additional atoms and their ionization energies would also be plotted. Is this clear?
Yes, sir.
I said, so let's try and solve questions now of ionization energies. We're pretty much done. If you have missed anything, we're going to cover that during the question. So a lot of these questions, you remember, comprehension is almost 50%. Sometimes it's more than 50% of the question. The concepts are easy. It's the comprehension of the question that's slightly more difficult. So if you look at this question or this question, for these two questions, 60% is comprehension. It's trying to understand the question. The rest is easy. So let's try and figure this one out. Which element has the second smallest atomic radius in its group? So comprehend the question. What is it saying? Second smallest atomic radius in its group. What does that mean? So here's my periodic table. So second smallest atomic radius in its group. So let's talk about this group. Which one is going to have, let's look at group 1. Which one is going to have the second smallest atomic radius? What happens to the size of atoms as you move down the group? Anyone, what happens to the size?
It decreases.
It increases, it becomes bigger, you've got more electrons down the group.
Oh, yeah.
Down the group, the number of shells, they continuously, this one. So down the group, the number of shells, they constantly increase down the group. Whenever you go downwards, there's an extra shell that's added. So that's the first thing. He's saying second smallest atomic radius. That means it's probably in this period, this one over here, period number 3. Like the first one is lithium, the second one is sodium. So the second smallest, the smallest would be the top one, the second smallest would be the second one. So he's talking about an element that's in this row. Is this clear? TK, is this clear, the first part?
Yes.
Then it says, and it has the third lowest first ionization energy in its period. So, from this I've deduced that it's in period 3, right? So it's a period 3 element. And then he says that it's the third lowest first ionization energy in its period. So across the period, he's talking about the period. And it's the third lowest. So it has to be the third lowest across the period, in its period. So our period was this one, period number 3. So which one out of them across the period? We're moving across the period. So be careful. What happens to the first ionization energies when you move across the period? We just did that. So this is what happens to the ionization energies when you move across the period. So we're looking at period number 3, right? So which one has the third lowest? Which one is the lowest? Sodium is the lowest. Which one is the second lowest? That's aluminium. Which one is the third lowest? That is going to be magnesium. Is this clear?
Yes.
So the answer is going to be, it's going to be magnesium. For this particular question, it's going to be magnesium. So remember, it's all about comprehending the question. First thing, second smallest atomic radius, so that must be an element in period 3. That must be an element that is second from the top. Okay, so it must be somewhere in this. And then he talked about that in its period, it had the third lowest first ionization energy. So this is what we did. The third lowest first ionization energy belongs to magnesium. Okay, count from the bottom, the lowest. Aluminium is the second lowest. That's the third lowest. So hence it's magnesium. Is this clear to everyone? Alicia, is this clear? Aisha? Anna, is this clear?
Yes, sir.
I said next one. Next one is probably even trickier. I mean, this one is like 80% comprehension. It's like your knowledge of is not really very helpful. It's more about comprehension. So you've got element X has a higher first ionization energy than element Y. So that's one information. Remember, he's talking about the first ionization energy. So first ionization energy of X is greater than the first ionization energy of, so it's more difficult to remove electrons from X compared to this other element, which is Y. I mean, that's the first thing. So what I'm going to do is, and he says that two students state what they believe is one factor that helps to explain this. So forget the two students. I'm just going to focus on this. The first statement. He's saying what could X and Y be? As the first thing is, I'm going to try and eliminate options. X is going to have a higher first ionization energy. So I've got carbon and boron, right? So carbon and boron are in the same period, right? So which one? Remember, X is, if I look at option A, X is carbon. So carbon should have a higher first ionization energy compared to boron. So let's have a look at the, this is your carbon and this is your boron. Boron is in group 3. That's where the dip occurs, and carbon has a higher ionization energy. So the first statement, the first fact that he told us, I mean, this is X, this is Y. So that means the first option, I mean, if I just look at the first statement only, that means the first option looks correct. Is this clear? I mean, at the moment. I haven't read the other options, but the first information that was given fits with option A. Okay, is this clear?
Yes, sir.
I said then.
Yes, sir.
I said, but I haven't read the whole question, so I'm just trying to eliminate the wrong options. I said magnesium should have a higher ionization. If option B is correct, then magnesium should have a higher ionization energy compared to aluminium. X should be greater than Y. So Mg and Al, look at where they are. I mean, they're also across the period. So you've got Mg and you've got Al. So Mg is having a ionization energy that's greater than Al because there's going to be a dip at Al at group 3. So you're moving across the period, there's going to be a dip at group 3. So that is also, I mean, that is also correct. Magnesium has an ionization energy that's greater than aluminium. And so what about the next one? Let's look at option C. Is that correct or not? Oxygen and nitrogen. So oxygen should have an ionization energy greater than nitrogen. So let's quickly have a look. Where's oxygen? Oxygen, so this one is wrong. Like the first fact that he told us does not fit with this. The first fact was that X should have an ionization energy greater than Y. But over here, X has an ionization energy that is actually lesser than Y. Y in this case was N. So that means I can eliminate this option. That's gone. Because the very first fact that he told us about X and Y, that's not correct about them. Is this clear?
Yes.
So then you've got option D. Is option D, I mean, the first fact is that matching D or not? Oxygen and sulfur. So where are oxygen and sulfur? Oxygen should have a greater ionization energy. So you've got, if you look at the periodic table, now this is not across the period, this is down the group. What happens down the group? Oxygen, the one that is at the top, that will have a higher ionization energy. It's going to be more difficult to remove electrons from a smaller atom because the electrons are going to be closer to the nucleus and they would be less shielded. And so because of these two factors, it becomes more difficult to remove electrons from oxygen compared to sulfur. Down the groups, it would be easier to remove electrons from sulfur. Is this clear?
Yes.
So D is also correct. Oxygen is having an ionization energy because it's a smaller atom, it has lesser shells, it's more difficult to remove electrons. Sulfur is a bigger atom, it's got more shells, the electrons are further away, so it kind of becomes easier to remove electrons. So the very first we eliminated C. Element X has a higher first ionization energy than Y. So A, B, and D can all be correct. C can never be correct. Okay. So hopefully this is all clear. Okay. Alicia, is this clear? Mariam, Hania, is this clear? Achha, but we have to figure out what the answer is now.
Yes, sir.
Okay, let's read the next one. Now he's saying two students. Now this is again more comprehension. Okay, less knowledge. Knowledge is not that important. Comprehension. So two students state what they believe is one factor that helps to explain this. So student one gave a reason. Student two also gave a reason. So I'm going to write down the reasons. Why it does, and I'm going to write down the reasons for each one of them. So why is carbon having an ionization energy greater than boron? So why is that? The reason that is true is, why was carbon having an ionization energy greater than boron? Because across the period, what happens? You've got more protons, right? I mean, that was the general trend. When you move across the period, why was it more difficult to remove electrons from carbon? You got more protons, and the distance also slightly decreases. So there are two factors. When you move across the period, carbon has a higher ionization energy because it has more protons. It's got 6 protons. Boron has 5 protons, so more attraction for electrons, and it's also a slightly smaller atom because across the period, the size of the atom slightly decreases. So two factors. First one, carbon has more protons, and its distance decreases. Distance is lesser as well. Is this clear?
Yes. It's basically the atomic radius is lesser, right?
Yeah. The atomic radius or distance of the electron from the nucleus is lesser. So what happens? So I'm going to write down all the reasons. Okay? Then I'm going to look at what student 1 and student 2 were saying. Now we've got magnesium and aluminium. Why is magnesium having a higher ionization energy? What's the reason for that? So in the case of magnesium, why was magnesium having a higher ionization energy compared to aluminium? Now the reason for that was, why was there a dip at group 3? Because in group 3, I mean, you can call this aluminium, like it's the same trend followed. The electron is removed from a higher energy p orbital, so the electron is further away. In magnesium, like because the same trend is followed, so I'm going to like in the next group, it's going to be sodium, magnesium. Group 3 would be aluminium and so on, right? And silicon, etc. So the same reasons would apply. They would have exactly the same electronic configuration, except that there's going to be an extra shell. So the reason is, in aluminium, electron is removed from an orbital which is much further away, and it is more shielded. In magnesium, the electron is removed from an orbital which is less shielded and closer to the nucleus. So that's the reason why it's slightly more difficult to remove electrons from magnesium compared to aluminium. So it's the group 3 dip that you have to talk about in this case. So I'm going to write that that in Mg, electron is removed from a subshell that's closer to the nucleus. And if it's removed from a subshell that's closer to the nucleus, and it's also less shielded as well. Or vice versa, in aluminium, the electron is removed from a p orbital, which is much further away, more shielded. Okay, so that's the reason. So what about we can ignore C because C did. I mean, even the very first information did not match with C. Let's look at D. What's wrong with oxygen and sulfur? That was down the group. So what happened down the group? That wasn't across the period. That was down the group. So what happens down the group? Oxygen has a smaller atomic radius. So oxygen is a smaller atom and it's less shielded. Or vice versa, sulfur is a much bigger atom and it's more shielded. So that's what's happening down the group. Okay, all three reasons. Is this clear? A, B, and D. I've given you reasons for why X is having an ionization energy greater than Y. Okay, is this clear to everyone?
Yes, sir.
Okay, Zari, is this clear? Zahib, Rubab, is this clear?
Yes, sir.
Yes, sir.
I said now, so two students are making a statement. Okay, again, more comprehension required. Student 1 and student 2. X, and he says that only one of the students is correct. So one of the student has to be correct, the other one has to be wrong. So I've written down the explanation or reasons for that. So both students, I mean, the answer is the one where one of the student is right and the other one is wrong. So student 1 says X has a higher ionization energy than Y because an atom of X has more protons in its nucleus than an atom of Y. So this applies to A. C has more protons, right? So an atom of X has more protons in its nucleus than an atom of Y. So this only applies to C, right? So that means one of the student, I mean, if I look at option A, one of the students is correct for option A. I mean, this is student 1. I'm going to call it S1. So S1 is correct for A. ठीक है, बल्कि write it over here. S1 is correct for A. Is this clear?
Yes.
And student 1 is actually wrong for the other two. I mean, his explanation is actually incorrect because oxygen actually had fewer protons. The reason oxygen, it was more difficult to remove electrons from oxygen was that it was a smaller atom and the electron was much closer to the nucleus because you were moving down the group. As a similarly, the reason why magnesium it was more difficult to remove electrons from magnesium was that the electron was much closer to the nucleus because the subshell was closer to the nucleus and less shielded. Not because it had more protons, it actually had lesser protons. So student 1 is correct for the first one, but he's incorrect for the other two. So let's look at student number 2. It says X has a higher first ionization energy than Y because X has a smaller atomic radius than Y. So he's talking about the atomic radius. The factor is atomic radius. So for which explanation is student 2 correct? Distance is lesser. So that means student number 2 is correct for the first one. Right? Because I told you that when you move across the period, the size of the atom decreases, carbon becomes smaller. So distance is lesser. TK, we did talk about it. So the atomic radius, you got a smaller atomic radius, right? What about is student 2, his explanation that the smaller atomic radius thing, is this correct for B as well? The electron is removed from a subshell that's closer to the nucleus. So it's again closest, the smaller, the atom size is smaller. So he's also correct for, student number 2 is also correct for B. And then he says that X has, the student number 2 is actually incorrect for this one. I mean, this is wrong. The reason student number 2 is incorrect is that when you move across the period, the size of the atom gradually decreases because you've got more protons. The electrons are kind of more strongly attracted to it. Okay, so aluminium has more protons. So when you move across the period, this is what we studied. that when you move across the period, you got more protons in the nucleus. So the shells are more strongly attracted to the nucleus. So there's a gradual decrease in atomic radius. So when you move to the right, aluminium is somewhere over here. Magnesium is somewhere before that. Aluminium has more protons. It's got 13 protons. Magnesium has 12 protons. So student 2 appears to be incorrect in this one. That the atomic radius is actually not smaller than Y. Magnesium is going to be bigger than Y. I mean, the size of the atom would be much bigger than Y. And let's look at option D. In option D, atomic radius is a factor because oxygen is clearly a smaller atom, sulfur is a much bigger atom. So, which is why student number 2 over here is correct. That oxygen is a smaller atom, so it has a smaller atomic radius than Y. So it's a smaller atom. So hence student 2, the explanation is correct. Achha, is this clear so far?
Yes, sir.
Yes, sir.
It's understandable.
Achha, now the last thing is only one of the two students is correct. So that means it's going to be option D. Like the options that he had, only one of the students has to be correct. The first one, both of them are correct. I mean, both of the explanations fit with this one. The second one, both of the explanations are actually incorrect. And the last one, student 2 explanation is correct, that it's got a smaller atomic radius. Oxygen has a smaller atomic radius. Students 1's explanation is kind of incorrect because he's saying that it's got more protons. Oxygen doesn't have more protons than sulfur. So hence the answer is D. I mean, this is kind of a tricky, it's a more comprehension question. This is a difficult question. Mostly in your MCQs, you don't have that much time. You're going to get 2-3 MCQs similar to this in your exam as well. Most of the MCQs are going to be, you can solve them quickly, but there would be some problematic MCQs like this one, which would be much harder to comprehend and understand. Achha, is this clear? This one?
Yes, sir.
Okay, apart from this, the rest of them would be kind of easy. This is slightly difficult, okay? Because every time he was making it trickier and trickier. So you have to fit or get all the information together. So this one hopefully is much easier. He's saying which term can be illustrated by an equation that includes the formation of a positive ion. So ignore these two for now. First, ionization energy. What's, like, if I talk about the first ionization energy of sodium, what's the reaction? Like, I'm trying to remove the first electron. So what would be formed? It's going to form Na+1, and one electron would be lost, and they should be gaseous atoms. I mean, that's the definition of ionization energy, that it's the energy that is needed to remove one electron from 1 mole of atoms, like 1 mole of electrons from 1 mole of gaseous atoms to form 1 mole of +1 ions. So it is the formation of a positive ion. So the first option is correct. Is this clear?
Yes, sir.
I'm not
Yes,
going to.
sir.
I said 2 and 3 are not about ionization energy, so we're going to ignore those. I said then this one is also slightly tricky. That is saying that the relative first ionization energy of 4 elements with consecutive atomic numbers. So it's consecutive atomic numbers. You're moving kind of across the period. Like consecutive proton numbers, that means that it's 5, 6, it could be, I mean, he's talking about 4 elements, right? So it could be 5, 6, 7, 8, like these 4 elements. Or it could be 9, 10, and then the period switches. It could be 9, 10, 11, and 12. Or it could be 11, 12, 13, 14. So there are 4 consecutive elements. So it's not necessary that they're all in the same period. Like if you have 4 consecutive protons, if you're starting at oxygen, then 8, 9, 10, and then there's the last one is in the next period. So, but they are consecutive protons, right? The elements have consecutive protons. So where's the graph of, this is a graph of consecutive protons. Like lithium is 3, 4, dip at 5, 6, 7, dip at 8. I mean, I'm talking about the proton number. 9, 10, then the period switches. Then all of a sudden there's a dip. You move to the next period. Sodium is again group 1, that's 11, 12, 13, 14, 15, 16, 17, 18. And after that, you switch the period again. Then there's going to be another dip. Okay, the same trend would repeat. So which part of this consecutive proton, and I drew another graph as well, which was over here, which had, I mean, this one had your, so consecutive protons, always a dip. Once you reach group 0, the next period, the same trend repeats. So which part of this consecutive proton ionization energy is this graph? Where does this graph belong? There's a rise. First one is the lowest. Then element B, there's a rise. Then there's a huge dip at C and then D. So which part is this? This is going to be this part. Like it might be fluorine, neon, and then there's going to be this huge dip at sodium and then Mg. Is this clear?
Yes, sir.
Yes, sir.
Okay, so he has, I'm going to highlight that. So what he has done is he is only discussing this part, 4 consecutive protons, right? So that means the period is switching somewhere over here. Neon, noble gas, then you move to the next period. So there's a switch that's happening. So that means the first one is in group 7, then there's noble gas, then there's group 1, then there's group 2, right? So if I go back, so A must be in group 7, which is now 17. This is group 18, and then you have group 1, and you've got group 2, right? So which one would be forming a covalent compound with the formula HX? I mean, this is a noble gas, right? So that's out of the question. That will not form any compounds. This is group 17. Assume that this is Cl. So with hydrogen, what if it reacts with hydrogen, what would be formed? It's going to form HCl, right? And it's a covalent molecule. Is this clear? The option is going to be A.
Yes, sir. It's clear.
Yes, sir.
Okay. I mean, this would be potassium then, like Cl is 17, then 18, that's argon, then there's the next one is potassium, that's 19. Potassium would also form the same formula, it's going to be KCl, except that it's going to be ionic, not covalent, because it's a metal and a non-metal, positive ion, negative ion, so it's ionic. So hence, the only thing, the answer is going to be A. I said next one. X is an element that has its outer electrons in the 4th principal quantum shell. So 4th shell, that means, what does that 4th shell mean? 4th shell means you're in the 4th period. I mean, he's talking about these elements. Okay, so the electron is in the 4th shell. So it's got to be these elements. And the next part is, it has a higher first ionization energy than calcium. So it's got to be higher than calcium. So what happens across the period? Remember, it's a 4th shell. Okay, the element belongs to the 4th shell. So I'm going to sketch the 4th shell. So it's going to be potassium. Then there's going to be a rise at calcium. Then you have these transition metals, right, in the 4th shell. Then there's going to be a dip at group 3. So the ionization energies are going to dip. Okay, so I mean, ignore all the transition metals for now. Okay, so it's going to be group 1, group 2, there's going to be a dip at group 3. Then at group 3, then there's going to be group 4 and group 5, they would rise. Then there's going to be a dip at group 6. Then there's going to be group 7 and then noble gases. Okay, so this is what the sketch would look like. Okay, so, and we're only talking about these elements over here. Right, I'm not talking about the previous period. He specifically stated that it has to be quantum shell number 4. So it has to be an element in the 4th period. So calcium is over here. So he said that the ionization energy should be greater than calcium. This one has the lowest, rises, dips again, then starts to rise again. Then group 6, there's going to be a dip, rises, right? So it could be an element which should have an ionization energy that is greater than calcium. So it must be any one of these, right? Is this clear? Yes or no? Is this clear? Anna, is this clear? Mahat?
Yes.
Acha. So calcium is because calcium is over here. So across the period, I just ignored all the transition metals. Okay, so imagine there's this. Okay, because transition metals, they don't have a lot of variation in ionization energies. That's not in your course at the moment. Just imagine that the ionization energies barely change. So he was talking about having an ionization energy that is greater than calcium. So it could be any element: germanium, acetylene, selenium, bromine, and krypton. So the answer is going to be, for this question, it's going to be bromine. Okay, that's one. What about the other one? So what else did we have? Krypton. I mean, krypton is going to be the highest, so krypton is also there. Not xenon, is it? Is xenon going to be there? Xenon is lower down in the period. So xenon is probably not going to be there. It's going to be lower down, so its ionization energy would be lesser. As you move down the group, the ionization energy would decrease. So not xenon. So the answer is going to be, the first two options are going to be correct. Is this clear?
Yes.
So just once, how do I clear this? 6 seconds. So now the next one is, again, it's this is period number 2, period number 3. In period number 4, you get these transition metals in between. So it's the same, almost the same graph, rises, dips, but the same sketch if you can ignore the transition metals. So anyways, which statement about the elements is correct? P and X are in the same period of the periodic table. So same period of the periodic table. These elements are, like these elements over here, they are in the same period. These elements over here, they are in the same period. These elements over here, they are in the same period. So P and X are definitely not in the same period. Like this is group 1. You got group 2, dip at group 3, 4, 5 rises, 6 dip, 7, 8. Then you move to the next period. Again, group 1, 2, dip at 3, 4, 5, 6, dip, dip. Then you've got 7 and you've got 8. So they're in completely different periods. This is period number 2, this is period number 3, this is period number 4. So is this clear? The first option is not correct.
Yes, sir.
So the first option is not correct. So then there's a general increase from Q to X is due to increasing atomic radius. So why does ionization energy increase across the period? Because I just told you that you have more protons. That's why it increases. Okay, this is what we have been studying. Why is there a general increase across the period? Because you got more protons. You got more protons and there's stronger attraction, more difficult to remove electrons, and the distance also slightly decreases. So over here, the general increase is, the distance is actually decreasing. So that is also incorrect. Like if you move across the period, you got more protons and slightly lesser distances. So what about C now? The small decrease from R to S is due to decreased shielding. So there's a dip at R to S. This is group 3. Why is there a dip at group 3? The dip at group 3 is that at group 3 the shielding kind of increases. The electron is slightly further away. It's more shielded. So that's why there is a dip at group 3, because the orbital is slightly further away. So the small decrease is due to increased shielding, not decreased shielding. Is this clear? ठीक है, is this clear? Zari, is this clear?
Yes, sir. It's
Anya?
clear.
Yes.
That's the last one. The last one is going to be correct. Hopefully, it's correct. The small decrease from U to V is due to repulsion between paired electrons. So U to V, that's group 6. This is group 6. 1, 2, dip at 3, 4, 5, and then there's another dip at 6. So why is there a dip at 6? Because you've got paired electrons and they repel. That is what happened. Like before nitrogen, where did it go? Just a second. So before nitrogen, you had all of them having had 1 electron each, right? But when you move to oxygen, you had an extra electron, so the orbitals became paired. And the electrons had mutual repulsion, and it became easier to remove electrons, which is why you had a dip at group 6. So the answer to this one is repulsion between paired electrons. That is correct. Is this clear?
Yes.
Yes, sir.
So okay, try revising. I mean, the theory questions are a lot simpler. Okay, the MCQs for this one specifically are kind of really tricky. It's more comprehension and less about your understanding of the whole thing. I mean, you need your concepts, but you need a lot more practice. Okay, your comprehension skills can only increase with a lot more practice. Okay, so we're going to continue with this in the same past paper questions. We'll do a bit more, TK, and we'll continue tomorrow, TK. Okay, everyone.
Okay, sir. Allah
Okay,
Hafiz.
sir.
Thank
Allah
you.
Thank you,
Hafiz.
sir.
Allah Hafiz.
Take care, Allah Hafiz.